All right, so here we're on 6.1, which is the table method, which is an introduction to the simplex method. So we'll work some exercises in this chapter, or in this section. All right, so the first one it says, in a basic solution A, so basically we're looking at first line here, which variables are basic? So those are going to be the non-zero, okay? So non-zero are going to be S1 and S2. Now in solution B, so that's the next line, which ones are non-basic? And so those are going to be the zeros. All right, so that would be X1 and S1. And non-basic, so those are the zeros again on, now we're on line C. So the zeros are X1 and S2. And then the basic ones, we're going to do the non-zeros for D. The non-zeros are X1 and S2. Now, which of the six basic solutions are feasible? So feasible are going to be the non-negative only. Okay. So the non-negatives, well, this one is a negative, so it's not going to be, that one's not going to be, but those are positive, there, and there. So A, B, E, F, it looks like are the non-negatives. So A, B, E, F. So those are all the non-negatives. So those are all feasible solutions. Now, which ones are not feasible? So those are the negatives. And those are going to be which ones? C and D. And finally, we're supposed to use the basic feasible solutions, so A, B, E, and F. Well, actually, we're going to look at all of them, but we know that the C and D are not feasible, so those we're not going to actually work on those. But which ones are going to be the feasible solutions to maximize P at 2x1 plus 5x2? So what we'll do is we'll just kind of go up here and we'll start working our way down. So for A, P is going to be equal to what? Well, it's going to be the 2 times x1, which is 0, and then plus a 5 times x2, which is 0, which gives us 0. Okay, well, that's pretty small, so I don't think that'll be a maximum. Here we'll have p is equal to 2 times 0 plus 8 times 5. Well, put those backwards, but that's okay. So that's 40. So that's pretty big. C doesn't work. D doesn't work. E, now we'll have P is equal to 2 times 9 plus 5 times 0, so that's just 18. And then F, it looks like we have P is equal to 2 times 6 plus 5 times 4, so that's 20 and 12, so what's that, 32? And so if we want to maximize this, then we want the biggest one, so it looks like the biggest one is going to be that. And so that will be our max P is equal to the 40 when x1 equals, it looks like a 0, and x2 is equal to an 8. So that would be maximizing this set of uh, the objective function as well as the different subject to functions. Okay. All right. So that's 21 through 27. So let's stop there and we'll come back for some more.